discussing any technical details as such, Okay, Ahmed
Okay.
can record. I don't know. He is able to record. Okay, good.
Yeah, I
Oh,
tried to I can record.
All right,
okay,
good,
okay. No problem.
good.
Thank you, Ahmad.
No problem.
Okay. Yeah. So as I was saying, the main aim of multiple regression analysis is prediction, right? So for prediction, uh, uh, this application will be useful in several situations. Okay. Say, for example, for sales forecasting, you want to forecast the sales, which is a very important event for any or an operation for any business, right? So here, when you are forecasting the sales, what are the things it may be depending on? There will be several factors here, right? How much you're spending on advertisement, not just the total spending. Maybe you are spending some amount on the social media, on the newspaper. There are several ways in which you can spend on advertising. Plus the other areas that the sales would be dependent would be the pricing strategies that you have, the season in which you are actually selling out this or forecasting this particular product. Maybe some external factors, maybe there is a some kind of event happening in that area. Okay. So that might affect that might have an effect on the sales. Maybe it's some economic indicators like the GDP has risen or it has fallen, or maybe the CPI, certain indices, economic indices, if they have changed, then again the sales would be affected. So there are so many things, other than the internal factors. There are so many external factors also, and you can have a numerical version of those particular factors. Then definitely all of these data will help you to understand what would be the sales. Now, given all of this information, okay, you would want to include as many relevant factors as possible. And all the factors that I told, they are independent of each other, right? Did you notice that? So how much you are going to spend on advertising, how much is the pricing that you are going to keep, what is going to be the season, what are going to be the economic indicators. Most of these are supposed to be not related to each other, but together they will influence the sales, right? So in this situation, multiple regression analysis is the best analysis method that you can apply here, right? So that you can forecast the sales. And remember, all of these, and if you notice, all of these factors that we considered, all of these variables that we considered, they all can be represented numerically, right? The second application is in market research. So when will you use regression analysis, multiple regression, especially in the market research? So especially if you want to find out, how the customer's behavior is, what kind of preferences the customer has. So here you would be looking at the age, the income, the gender, right? So these are the things mainly you will look into the demographics part. Then in terms of the customer satisfaction, how satisfied he has been with certain other products. Okay, or what are the product features he's trying to look at, what is the pricing he's trying to he's comfortable with. So all of these can be the main factors which will help us to understand whether this customer is going to buy the product or not. And based on that, you can understand who are these people who are actually buying the products, who are the people who are not buying the products, so that you can target these people in your marketing, or maybe make certain changes in your product features or your pricing, right? So all of these strategies can be decided only if you know what exactly the customer behavior or preference may be, right? So maybe that say for example, from the government records that the next 5 years or next 10 years, there are more of the majority of the population is going to be in this particular age group, right? Say for example 20 to 30, that is the age group. So usually such statistics release. So that this is the majority chunk of your population age group, and you have to target these people. So what are the factors which will help us to based on the factors, of course, which will help you to predict whether your customer is going to actually buy the product or not. Again, you can use multiple regression analysis for that. Again, customer segmentation, as I mentioned, you can use multiple regression analysis, so that based on certain demographics and so on, as I said in the previous case, it's related to that. So you can understand whether you can what kind of marketing campaigns you need to create, okay, so that you can see that the targeted customer group is being met, okay. Another use is in resource allocation, okay, whenever you want to do budgeting, okay. So here again there are so many factors which will actually help you to understand what budget allocation has to be done, okay. So here again, there are several factors from right from the resources that you have and how much you need for their maintenance, whether it's your fixed assets or maybe your human resource assets. So all of these, and plus the business performance itself, all of these can be contributing factors to know what kind of resource allocation strategies you should have, right? So you can do it individually for each of your resource. Okay, in that case, again, you can apply the multiple regression analysis. Another very good application is in risk management. So here again, there are various types of risk, right? There is a financial risk, there is market risk, there is operational risk, strategic risk. So different kinds of risk can be, predicted, okay, based on how much, maybe based on the investor itself, based on the plan that you have for investment. So based on that, maybe you are talking about a particular investor who is investing in stock, okay. So you would he would have invested in certain stock which are high risk, okay, but also high return, maybe low risk and low return. So there will be a combination there, right? So what is the total risk there involved, and what kind of customers are likely to engage in certain what kind of stocks, okay. So again, all of these factors will contribute to the total risk that you're exposed to in your portfolio. So again, here you can use multiple regression analysis to forecast the risk there. Okay. Same way for supply chain and optimization, keeping in again, there is a lot of factors here, including, what is the demand, what is the time you have for the delivery, the transportation cost, how much time the supplier will take, what kind of pricing the supplier is giving you. Again, all of these can be converted into numbers, right? And you can come up with, solutions that can help your organization to reduce the cost, maybe to enhance the customer satisfaction, maybe. So all of these can be predictors, okay, to predict the cost, or maybe the I'm sorry, the cost, or maybe the customer satisfaction. So you can predict that as well. Another good situation is employee performance. So in HR also, multiple regression analysis can be used. Here again, you can consider various factors like how happy the employee is within the organization, how is his performance within the organization, what is his plans for of being retained in the company or continuing with the company. So all of these variables can help them to decide how much they should allocate for maybe training, or maybe they would want to decide all of this on the compensation, or maybe they can decide on how they can improve their work environment, or maybe improve their leadership style. So again, all of these areas can all of these factors can contribute to any of these predictions or forecasting of the training, of the compensation, and so on individually. And you can create regression models here as well, okay. So what is the benefit of this? You would not be spending unnecessary on people who are not, going to be there continuing with your organization. You would not be spending or maybe increasing salaries of people who are not going to be retained, maybe. So all of these factors can help you to predict and make those strategic decisions once you apply the right regression analysis with the right set of independent variables. Finally, financial analysis I've already covered, but here again, any kind of trends in the market you want to, observe based on historical data. You can observe if any kind of, seasonality was there in the data, and this way you can, forecast for the next year, maybe. Okay. So it's not just for the, individual investors, it's for the whole company itself. Okay. So you can take various factors into consideration, the expenses, the revenue, the profitability, the market value. So everything can help you to predict what would be the final financial performance of the organization. Say, for example, you can have data. Say, for example, you can take how have certain banks performed in the previous years. Okay, so and whether they have continued their running or they have become bankrupt. Okay, so if you have such a data, okay, and of course, when they release timely, the banks release their data on what their revenue was, what their expenses was, what was the profits, what were the dividends paid, and so on, right? So based on all of this data, you can then make a prediction of if this is going to be the trend of certain bank in the future. Okay, there are high chances that this bank may not become bankrupt, or may not, or may continue, it's running. So these kind of predictions can be made here, right? So all of these are examples of how you can apply multiple regression analysis. So maybe you can expect some question there where you have to pick up two or three such applications and explain them of using multiple regression analysis. So I hope you have understood the concept and what kind of factors, mainly in each of these scenarios, you have to explain, you will have to explain and understand what will be your independent variables. Okay, now that you know how to apply this method, you are in this position to tell me what are independent variables, what will be your variable which you are forecasting, or which is your dependent variable, right? Okay, and how will the final model look like? For example, why, in the case of our first example, say sales. Okay, so why is your sales, right? And then what are your independent variables here? It will be the advertising, maybe on Facebook, advertising spent on Instagram, advertising spent on the newspaper, on the billboards. Okay, these are different factors, plus the pricing that you have kept for the product, and so on. So these are the independent variables, so you can explain that. Okay, so I hope in each of the case you have understood what will be your independent variables, what will be your dependent variable. Is that clear? Any questions that you have?
No, nothing from my side.
No,
Anyone
ma'am.
else? Okay, all right, so again we will do a short R program. Okay, I will put this program on WhatsApp again. Okay, it's a very short program that we will run, and we will see how to interpret the data that you observe there. Okay, or the okay. Can you see my screen with the R code?
Yes, ma'am.
So to get this data set, first of all, I want you to install this package, which is called as data RIUM, data RIUM. Okay, so for this, you go to install. Okay, and under packages, please type in data RIUM. Okay, this is the package, and click on install so that you have this package. I already have it, so I will not install it again. This is the name of the package, DATARIUM, because our data set is in that package. We are not using any new method from any new package. It's just the data set.
Miss, what is the data set? What is the package that we are to install?
The package name is DATARIUM. Just a minute, give me a
Okay,
moment.
ma'am.
Yeah, can you or have you downloaded this package DATARIUM?
Yes.
Done. Okay. So once you're done, just run this first line. Okay. Basically, this is another way of storing marketing. Okay. This is the variable name. Marketing is the data set that will be stored from data RUM. Okay. So run the first line. Now, marketing is the name of the variable. Okay. So let's have a look at the first 4 lines of marketing. So what do you see here? YouTube, Facebook, newspaper, and sales. So this is the expenditure you're doing. Okay. And this is the sales that you're getting. Okay. So this is about the marketing set that you have. So obviously you're going to forecast the sales based on the spendings that you have done on YouTube, on the ads for Facebook, on the ads in the newspaper. Okay. So are you able to see you can show me a thumbs up if you are able to see the head of the data set. YouTube, Facebook, newspaper, sales. Okay. All right. Good. Just give me 1 second. Okay. Next, we will create the model. Remember, it is the same way we can define it. Okay. Here I'm calling the model as MODEL model. Okay. LM is the function. It is in the base package, as you know previously. You don't need any extra package. It's in the base package. You start by writing sales. Okay, you can simply use the simple formula. Okay, sales, which is Y. Okay, and this is the symbol for equal to, which is the original model. Remember the model that we saw yesterday? Let me write it over here. Okay, it's the model is Y equals B0, right? Plus B1 X1 plus B2 X2 and so on, correct? So this is how our model is. So same way here, instead of the equal to, you need the symbol, this still symbol here. Okay. So you will use that symbol. The variables that you have to include is X1 is for us as YouTube. So as it is, you have to write YouTube, Facebook, and newspaper. And the data that you're going to use is marketing, which we have already loaded, right, into the marketing variable. So this is how you will write the model. I will run this code. Okay. So all of you run this line of code. If everything is good, it will just show you a blue line here, blue arrow here, or the greater than symbol. Okay. Next, let's have a look at the model itself. When I say look at the model itself, we are going to look at what are going to be the actual values of B0, B1, B2, and so on. Okay, and B3, of course, just 3 variables are there. Okay, and we'll also see the p-value, how strong the value, model is, and so on. So let's have a look at that. Look at this model. So summary of model. If you run this line of code, okay, I will just expand this so that we see everything here. This is your formula that you use. Okay, so have a look at the coefficients. Okay, so the coefficient is 3.52667 plus 0.045765 x1, which is YouTube, x YouTube. Okay. So I'll just show you how you will actually write the model. Okay. So y equals 3.5267 plus, which is your beta naught, okay, or beta 0, 0.0457 x, I will call it x YouTube, okay, plus 0.188 5x, that is for Facebook, plus, it shouldn't be plus, it should be minus, right? 0.001037 x newspaper. All right, plus epsilon, the error, right? So you will have to, given the output, you will have to write the model this way. Okay. Now, given this model, okay, if I ask you to estimate, okay, so I will just, I will just save this here. I will just save this here in the comment. Okay. So in case I tell you that, okay, in case I tell you that I'm going to spend, sorry. Okay, this is your model. You don't have to write it. It is not a code, line of code. This is just your model. Okay. So in case I tell you that you're going to spend, okay, say $100 on YouTube, okay, another 100 on Facebook, and $50 on newspaper. Okay. If this is going to be your, spending, what is your expected sales? Can someone answer this question? Is the question clear?
Yeah, again, it's $100 on YouTube, 100 on Facebook, and 50 on newspaper.
50
Yeah.
on the newspaper. Okay. So what is your expected sales? Tell me the prediction of the sales if this much is spent on each of these units.
Ma'am, expectations, like it could be near about 3 times how much we have spent.
No, you have the model here. Why would you do only 3 times? You have the model here. So what you will do, I will just show you. Okay. What did I say on YouTube? How much are we spending? 100. So I will replace X by 100 because I know now that I'm going to spend $100 on YouTube. Okay. Now what I will do, I will remove this Facebook. Okay. Because now I know X that I'm going to spend $100 on Facebook. So I will replace that with 100. Right. What should I write here? I
50.
deleted newspaper. Yes. Times 50. Right. This is the error term expected. What is the expected value of error? If your model is very good, what should be the error?
0.
0, right? We discussed this last class, correct? So if our model is really good, or we are aiming that it should be 0. So let's see what does the model give us. So I will remove the comment sign. I will just select this much part, okay, where I have done the calculation, and I will enter. So when I see the answer, I'm getting 26 point around. If you have used the same numbers exactly, you will get the same answer, but approximately 26, 27. That's going to be your sales, prediction of the sales. Is that clear?
Yeah. So is it like $26? Yeah.
Yes, $26. Okay. See, in the actual data, I had all mixed data. YouTube, how much ever, Facebook or newspaper. But based on all of the historical data, in the future, if I know that my budget is $100 for YouTube, 100 for Facebook, and 50 for newspaper, I can know from now itself, that I can expect a profit of $27. Is that clear?
Yes.
Okay. So how did I get these numbers? Go back to the summary of the model. You can see the estimates here of beta naught, beta 1, beta 2, beta 3. So whenever this model, this summary can be seen, you can create the model like this. Now I have highlighted it. You can write this model yourself, because there is no code for you to, actually do it, through any means. So you have to write the model yourself. Okay. And then whatever values are asked as input or given as input for you, you replace them in the right place and give me the estimate or the prediction. Is that clear? Okay. So this is how you will write the model from the summary. Okay. And you will predict the sales based on the inputs that are given to you. Okay. Now let's first assess the model. Okay, this is just so you know how you can interpret the summary details. So if you look at the individual variables, are all the variables good to go? We will not look at intercept, that's not really required. But what about YouTube? Is it good to go? Good to include in your model?
Yeah.
YouTube is, because you can see it's significant, right? Less than 0.05, which is good. Facebook,
Yes.
good. Okay. Newspaper,
No.
no, right? So what we see is that here is that newspaper is not contributing to the sales in any way. It doesn't matter if you advertise, less or more on the newspaper, it's not making much differences on the sales. Okay. Which is why including newspaper may not be a good idea. So let's now create another set of another model itself where we will drop the newspaper, we will not keep newspaper. Okay. So yes, before that, this is one more way in which you want to only, if you just want to see that block without the p values of the overall block and so on. Okay. So anyway, yes, one more thing in the summary is look at the r square. It's a good r square, right? 0.89. Okay, let's see if we, after dropping newspaper, we are able to come up with a better R square or not. We will keep that in mind. Overall, the model is also good because overall p value is less than 0.05. Okay. So let's see what is the differences if we drop. So now we are rewriting the model. Now this time you will notice that newspaper is not there. Okay. So I will run this. Everything is good. If you look at the summary, okay, we see that YouTube and Facebook, both of them are sufficient. Okay. 8972 is the R square, 8972. Okay. In the previous one also it was the same. So R square is not, there's not much of a difference, but at least you have those two variables that are really significant. Okay. All right. And let's also see the residual sum of errors. What is that? So this is the formula for that. Okay. So for this model, it is 0.1199. Let me also check for the previous model. I will run this line again. And I will run this. Yeah, residual is less. Okay. So to avoid any confusion, maybe you can call it as model 1 and model 2. Otherwise, you might get confused. So what you can do is you can call this model 1. Okay. Or let me call it as model underscore n, the new one. Okay. Let's do this. Okay. Model underscore n. Just change the second model as model underscore n, model underscore n. Okay. And here you will write the same lines again. And here only one change you have to do. You have to make it model underscore n. Okay. So this is the mean of the residuals. Okay. So if you compare these two values, okay, I will run this again and I will calculate both these values again. Okay. And what do I notice? For the new model, the residuals are lesser. The mean of the residual is lesser, which is good, right? So the second model is better here than the first model.
But how come it does not reflect this in this R squared?
In R square, it is not reflecting because maybe it is adding little bit, not much. Okay, it is ignoring the newspaper one. Okay, so it happens. It is in many of the data set it happens. But which is why I said you have to look at the post, part of it, where you have to look at the residuals as well. Okay.
Okay.
Another thing you can look at is, yes, the adjusted R square. This can give you a better picture. Okay, just look at the adjusted R square of the previous model. It is 8956 and this is 8962. So little bit difference is there, right? Although small, but you will know that, this has been taken care of.
Okay.
And I think this we have seen overall. And now this is better, right? We can also apply the other tests that we saw last class. Okay, I'm just showing you. You can do an ANOVA also. Okay, we will try this. It's not there in the line of code, so you can just write this to confirm which of the models are better. Okay, so model and model N. You can do this test as well. Okay. Let me try if this will work. Yeah, this is model 1, model 2. Yeah, we got higher, right? So model N, the new model is better. Since this p-value is more than 0.05, we'll say the new model is better. Okay. So you can confirm this with two of these ways, looking at the residuals and looking at this. Okay. You can also do the QQ plot and so on, same way. Okay, you can try that. Doing the QQ plot and looking at the residuals, if it's falling on the line or not. Okay, that is visually, but by actual numbers, these are the two things you can try. Okay. Is this clear?
Which package is ANOVA?
Otherwise, in the base package.
Okay, because it's telling me that it could not find.
I think so. It's in the base package.
Wait,
Let me.
I made like I put 2N in ANOVA, or maybe 1N.
Okay, 1N, yes. Okay. All right. So any other questions that you have, you can ask. That's it for today. Okay. I don't want to start with the new concept online. And we will meet next week, Monday. Monday will be our regular class. Okay. And Wednesday, we will do the presentation. Okay.
Okay, thank you. I will stop the recording now.
All right. Yes. Any other question, anyone? Otherwise, we'll just wrap up the session.